All right, everybody's here. Thank you for coming today, and welcome to reInvent 2019. My name is Doug Booth. I'm a Principal Business Development Manager for AWS. I've had the unique opportunity for the last 3 years to work with our customer, Amazon.com, on their migration off of Oracle to a world of database freedom. In our agenda, we will bring out our customer, Amazon.com, and they'll discuss the enterprise migration. We will cover the Amazon legacy database infrastructure, some reasons to migrate, some lessons learned and benefits realized. We will also cover some of the public case studies we've produced, where you can see highlights of 9 different case studies from teams that migrated and what some of their outcomes were. So before I bring out Thomas, I'd like to show you just a brief video.
The scalability of the AWS services are really important from a security perspective. Our Oracle environment was not able to scale to meet all of our demands.
Relational databases were a great technology in the 90s when they really came to the fore in the tech industry, and Amazon used them very successfully many years.
Today, we shut down the final Oracle database that used to run our consumer and digital business.
In that transition that we made to use AWS, we've gotten huge advances in availability. The site's more robust, in scale. We've gotten advances in lower latency, especially managed services, critical services that move to NoSQL stores like DynamoDB.
Do we have a permission to shut down the database?
Are we going to do this?
Yes.
Yes?
5, 4, 3, 2, 1.
All right.
Wow. Yes, so they actually did it, and we're very excited with that. It was a long process, and I was very excited to be able to work with Thomas. And with that, I'd like to bring out Thomas Park, Senior Manager for Business Data Technologies at Amazon.com. Thomas, come on out.
Thank you, Doug. As Doug stated, my name is Thomas Park. I've been with Amazon for almost 8 years. I started with AWS and later team in Virginia, and then another one in Seoul, Korea. In July 2016, I joined Amazon.com's e-commerce business to migrate thousands of Oracle databases to AWS. Today, I'd like to share some of the learnings and how we were able to migrate so many Oracle databases. Before I start, I would like to share a story about database migration. Let me first start it with a history of Amazon.com and how we ended up having so many databases. As you know, Amazon.com opened its door to the world in 1995. When you take a look at this web page, many of you would think that we'll need some help. In fact, a lot of help. Although the website was not that innovative, the back-end architecture was one of the most innovative systems at that time. We had web application server taking orders online, and then orders were stored in centralized Oracle database system. Once the items were shipped, we would then process the payments by integrating our bank to our customers' credit card companies before we complete the transaction. In 1995, this was an innovative system. However, we started to have some issues with our original architecture. As more and more customers started to order more and more items online, the database was processing orders starting to have issues. And sometimes we experience outages. These unexpected outages not only impacted our customers' ability to order online, but also stop us from shipping already ordered items and processing our credit card or payments transactions. So we had to change, especially our architecture. we decided to break up the single monolithic architecture into multiple services. Each service will have its own database layer that the service and database can scale independently. Ordering system will have its own ordering database. Payments service will have its own payments database. By decoupling the architecture, we were able to troubleshoot issues faster and to contain the outages by each service level. However, we found that going from a single monolithic architecture into multiple service-oriented architecture did not really fully address our relational database scalability issues. We still had to add more databases to scale. You see, when a relational database reaches 100% full due to data volume increase, you would need to vertically scale the database. But there is a maximum size limit where you cannot no longer vertically scale. We had to address these challenges and to implement different techniques to scale our databases. One of the techniques is called database sharding. This is how it works. When a database is 100% full, you will maintain a tracker in order to direct an application called to store your data into a different database. In this diagram, application is configured to store customer data 1 and 2 in database shard 1, and customer data 3 and 4 in database shard 2. This method was a convenient way to store additional transaction data without changing the data model or underlying database storage architecture. However, we found that as we were increasing the number of databases, the operation costs related to them also increased significantly. By 2017, OLTP database system had nearly 75 OLTP databases around the world, with over 75 petabytes of data. These systems were processing daily not only the millions of orders, payments, and fulfillments, but also the related data. Hence, these systems could not go down anytime. So how big is a petabyte of data? If you stack a pile of DVD as high as a 55-story building, the size of the data in these DVD is equal to a petabyte of data. Similar to OLTP system, our legacy Oracle database infrastructure, as well as the data warehouse system, was massive. Just for data warehouse system, we had over 50 petabytes of data, 75,000 data warehouse tables, and it was processing over 600,000 daily jobs a day. Over the 20 years since the data warehouse system was built, number of Amazon teams have published, consumed their data every day using this system. Now, Doug will speak about why we had to migrate these databases.
Thank you, Thomas. Now, let's talk about some reasons Amazon needed to migrate to a new platform. As we talk about reasons why, first we should discuss a few of the requirements that they had. They include service availability, data availability, and migration time. The service availability was required to operate, and scale data availability needed to be consistent. Migrations also needed to be done with little to no downtime. It's a very challenging effort when your website can never go down for maintenance. As we dive deeper, here are some of the primary reasons Amazon felt that they needed to migrate and move to a more free world. First, Amazon had scalability risks due to both data volume and an increase in global market expansion. Second, Amazon also had latency risks due to data volume, and transaction rates were increasing by the day. Third, there were cost risks due to hardware and software, and availability and price increases were also in the equation. Fourth, there were some data availability risks that were simply due to legacy code that just had not been updated. And finally, there were operations risks due to hardware provisioning and management, along with the time and effort and all the resources needed to deliver that actual capacity for something like a peak event, like a Black Friday, a Cyber Monday, or Prime Day. So the scaling issues were actually really broad, and they included some teams facing 60 weeks to scale for something like Prime Day. That's a tremendous amount of time and effort going into just scaling for the event. Even with scaling complete, Amazon was still at risk of failure. Even with the best support from the best providers, failure could still occur due to the traffic volumes and the business expansion. You know, Amazon never slows down. And we found we needed new ways to improve latency and maybe do so on 2x to 4x the traffic based on the business growth. That's a daunting challenge at an Amazon scale. Our customer was managing 75 petabytes of data, and it was growing at an exponential rate. Now, that's a lot of data, okay? And it takes a lot of effort to just operate it. It's also expensive to administer. It's also expensive to manage. Again, when you have teams of people managing to just scale or keep the lights on, that takes away from innovation. Some teams, once they migrated, actually saw 40% improvement in latency over their prior solution. And that was by moving to AWS managed database services like DynamoDB and Aurora. We also use Redshift in our Andes data warehouse. Hardware pricing and availability is challenging, and it can also be difficult on timing, and it can be unreliable if that hardware doesn't show up, and yet you've got a peak event that's ready to go off. It takes a lot of people, time, and effort just to manage the procurement, the PO process, and just to make sure everything is delivered and arrives. Additionally, the software pricing and some of the vendor tactics that we were challenged with were not healthy for the business. And so there was really, a change was needed. We also had some availability and operations risks. So this one was really critical to the business. They required the ability to scale both up and down. The and down is the important part of the message there. When we need to scale the network to multiple times over to support a peak event, you want to be able to quickly scale down and not be sitting on any idle capacity. We also needed to design for 100% availability, and the data needed to be consistent 100% of the time. That's a very difficult challenge to pull off at an Amazon scale. So Prime Day, it's a really interesting event for our customer. And it started only in 2005, but today it seems a very common term to hear. Prime Day is unlike any holiday because it's really not a holiday. It's an event that happens in the summer, shortly within a week or two after the 4th of July. To get a view of the kind of scaling we're addressing, in 2015, Amazon held the first Prime Day, and they sold 34 million products across 9 countries. By 2019, that had changed a lot. It had grown to 175 million products across 18 countries, but now it was 2 days. It became the biggest event in Amazon history, beating out Black Friday and Cyber Monday, which, that's a feat. That's a real feat there. So Amazon had demands on AWS that were great, but they also no longer had a year to scale for a peak event, because Prime Day well, now we're doing it about every 6 months. So it put additional pressure on teams to be able to scale for multiple peak events. with that, I'd like to bring Thomas back out and talk about some of the migration strategies and the lessons we learned through this process. Thomas?
Thank you, Doug. My responsibility when I first joined the consumer business in 2016 included managing all these data warehouse systems as well as OLTP databases while I was leading the migration effort. However, at that time, we kept adding more databases rather than deprecating and migrating. We were struggling to scale our database systems, and we were constantly worried about potential system failure due to a disk space. We were in trouble. We needed to change immediately in order to achieve our migration goal. As you know, we announced in October 2019 that Amazon's consumer business shut down or complete our migration effort by nearly shutting down 7,500 OLTP databases and migrate them from Oracle to AWS databases. This migration effort was huge, nearly 75 petabytes of data across many different Amazon teams, including Alexa, Prime, Kindle, and many more. But how do you deprecate and migrate all these databases to AWS without any downtime and loss of data? Today, I would like to share some of these experience and lessons learned from our experience. When we first started the migration project, we lacked visibility of our database and their ownership. See, databases were created and consumed by many different service teams, and there was no central tracking system to track them. So we had to increase our visibility of our legacy Oracle database infrastructure, database schema, and application dependencies. In our case, a single database can have thousands of tables, and these tables can be updated and modified by multiple service teams. So who should really take the ownership of migrating this database? The creator, the user, or the DBA? This was a huge dilemma. One way to identify the database user is to track database connection logs. We collected all the database connection logs and started to parse and count the connection information using AWS EMR clusters. This visual diagram allows us to answer questions like, how many Oracle databases do we have today? How many new Oracle databases have we launched today? Having a visibility of database infrastructure allow us to define KPIs and success metrics in order to track the migration effort. Once we had a better idea about the number of databases that were in our infrastructure, we found that we also needed more detailed information about the database schema, such as table usage. We also needed to increase our visibility of the database tables in each database. For example, we had to answer questions like, how many Oracle data warehouse extract jobs were running on a OLTP database? How many read or write operations were running on a database? Soon we started to collect information such as database CRUD operation, create, read, update, and delete operations. This picture on the right is a visual diagram of Oracle MView, which is materialized view dependencies. Once the Oracle MView allow the data replication from a single database to multiple databases. By tracking these MViews and the tables level replication dependency, we were able to track database migration status by each database table. Gaining a solid understanding of your database infrastructure and table dependencies allow us to realize that we also needed to increase our visibility of application dependencies. We wanted to know all the applications that were using the database and map all application SQL statements to a database infrastructure and tables. There are many different ways to do this, but there is one tool that we actually created. We created Java library wrapper to track all SQL execution of database query for centralized analysis. We use Amazon Kinesis and Elastic Cache and Search to capture and analyze SQL queries that were initiated by different applications. By monitoring these SQL queries, we were able to answer questions like which application was using which database tables. This type of visibility allowed the development team to plan the database migration. More importantly, though, software engineers started to gain more confidence about the database migration plan. By increasing our ability and the visibility to our database infrastructure, database schema, and application dependency, we were able to remove uncertainty and doubts about the database migration. With any challenging endeavor, you will always need executive support. In our case, we needed to accelerate such valuable support, as deprecating and migrating a number of databases impacted many different stakeholders throughout Amazon. During this migration journey, we found that many executives actually never track nor know how to track database migration project. We leverage AWS account and product teams to engage and build trusted relationship with our executives. We also identify internal AWS advocates, the people who are interested in learning about AWS technologies, to ensure that executives' concerns were properly addressed and mitigated. Finally, we've also built some tools and dashboard to inform and track database migration project progress by each executives. These tools and dashboard also provided our CEO to review each executive's database migration status on a monthly basis. I have to say that when an executive receives a call from the CEO about his or her database migration status, it surely accelerates and motivates team to focus and put the migration project on priority. Here's an example. Our database migration dashboard includes this chart, which shows the number of database migrated by month over month. Since the launch of the dashboard, you can see a significant jump in the number of migrated databases within 2 months and continue upward trajectory until the conclusion of the project. We found that many teams immediately leverage the dashboard's information and tools to identify database dependencies and to shut down unused and unnecessary databases. Even after we increase our visibility and accelerate executive support, we still had to confront additional FUD and real technical issues. FUD is fear, uncertainty, and doubt, and it's really different from technical issues. We face a lot of resistance to migrate Oracle databases, especially from our own Oracle DBAs. They wanted to add more database to address operational needs, whereas we had to deprecate them in order to completely migrate off of Oracle. We realized that gaining Oracle DBA support was critical for our migration effort. Many Oracle DBAs expressed a lot of doubts and fear about migrating databases. However, these doubts and fear, in fact, did not relate to technical or operational needs. You see, when you have people who dedicated their entire life and built their career on Oracle technologies, Oracle database migration was a huge curveball. There was a huge gap between their professional career and our migration effort. So we focus on providing DBA career path and training opportunities. I say to them, they will become expert in both legacy Oracle operation and new AWS database technologies. They will play a critical role in the biggest Oracle migration project in the world by demonstrating their expertise in both legacy and new cloud-based technologies. By addressing their FUD and gaining their support, our DBAs play a critical role in resolving real technical issues and accomplishing our goal to migrate all the databases. We also found that having an environment of force multipliers was a key to our successful database migration. We basically enable the enablers. At the initial stage of the migration, we noticed that many teams were making similar mistakes and were experiencing common blockers. Although we had workarounds and solutions for these blockers, many teams were not aware of them. Having an environment of force multipliers, we were able to enable the enablers by creating and sharing reference architectures, set of best practices, and design patterns for database migration. So in the next few slides, I'm going to share some of the examples of force multipliers that we created. Here's one such reference architecture that we created to share and then share with other teams for migrating Oracle to Postgres database. We have a legacy Oracle database on the left being migrated to the target database, in this case, Postgres, using Oracle, the database migration service. We have a data validation service on top to validate all the migrated data from Oracle to Postgres. In the far left, the service calls are separated into two. One for the service calls that have not been migrated, and one for the service call that have migrated. This is a typical pattern for migrating Oracle to Postgres. However, we actually ran into multiple issues when our target database, in this case Postgres, failed before all the migration could be completed. So we created another Oracle database in the far right to replicate the Postgres database using DMS. The purpose of this replication is to handle failback situation. Failback situation can occur when the target Postgres database fails before all the tables and data have migrated. In order to prevent any such service disruption, we set up another Oracle database, in this case, RDS Oracle in AWS, and replicate change capture data, CDC logs, from PostgreSQL back to Oracle RDS. Another example of creating force multiplier is writing blogs or maintaining wiki pages to share challenging situation or solutions. Here's an example of a blog post that was published in late 2018. This blog contains common challenges that the team faced while migrating from Oracle to Postgres. As you can see, there are a lot of common challenges, but today I would like to go over one as an example. One common challenge that we face as we started to migrate databases was data type differences. In this example, we noted that Oracle was more tolerant in treating empty string and null data. Let me tell you what I mean by that. When I insert a record as an empty string, Oracle stores it as a null, and you can actually query it using predicate where name is null, and both values will display. On the other hand, Postgres doesn't display the row with the empty string. When I query using the same exact predicate where name is null. To find the row in Postgres, I have to query using equal operator and look for the empty string in predicate. We learned these differences during our data validation tests. Some teams spend several hours or even days to troubleshoot this type of data validation issues. By sharing common database migration challenges and solutions, we were able to overcome these issues and accelerate our database migration time. Another challenge we had to overcome was how to migrate services without any downtime. Here's another reference architecture that we created to address this challenge. In the previous slide, I talked about using separate service call for both Oracle and Postgres databases. Probably many of you have wondered, how did you do that? Well, here's one way to make your database connection dynamically. We leverage AWS DynamoDB table and cache layer, the elastic cache, to store mapping information of each application module to a database engine. So for example, application A is mapped to Postgres database engine. Application B is mapped to Oracle. We also created connection pool with dual connection to both Oracle and Postgres databases. At runtime, each application module would determine which connection to execute that SQL based on the mapping information. In order to keep the data continuously syncing between the tables in Oracle and in Postgres database, we also set up AWS DMS replication. For example, when application B inserts a record in Oracle table B, AWS DMS will capture the change and replicate the Postgres table B. Hence, both table B in Oracle and Postgres databases will be in sync. Similarly, when application A updates a record in table A in Postgres database, AWS DMS will capture all the changes and replicate them to our Oracle database. We set up this DMS replication from Postgres to Oracle in case the Postgres database failed before we are ready to cut over our applications. This architecture allows the software development team to stagger their database migration by application module. Previous architecture was focusing on the migrating Oracle to another relational database, Postgres. But you may ask, what about migrating from Oracle to NoSQL database, such as DynamoDB? As you know, migrating your relational Oracle database to a NoSQL database may require you to redesign your data model. Many software development teams develop a dual write capability in order to address this challenge. A dual write capability can insert a new record or a transaction asynchronously to DynamoDB. This capability also allows us to validate our DynamoDB data model before we cut over our application. Once we confirm and finalized the DynamoDB data model, we migrated all the missing transactions from Oracle to DynamoDB using a tool called Data Backfill. We developed this Data Backfill tool in order to run in the background for a while, sometimes for a month, depending on how much old data you would like to migrate from Oracle to DynamoDB. We also created retry backfill process using Amazon SQS. Soon after we started using our backfill tool to migrate the data from Oracle to DynamoDB, AWS DMS team released a new feature to support Oracle to DynamoDB migration. So today, you do not need to create your own backfill tool. You can simply leverage AWS DMS tool to improve data backfill process and minimize the downtime. Finally, I would like to emphasize the importance of working with AWS team. During this journey, the AWS team worked closely with our executives, our engineers, DBAs, and program managers to remove technical obstacles, develop specific database solutions, and help us to transform our legacy Oracle infrastructure. If a company like Amazon can move so many Oracle databases used by so many decentralized, globally distributed teams to AWS, it's really within the reach of any enterprise. AWS team is committed partner, as well as they provide highly available and reliable database solutions. Now, Doug will share some of the benefits that we realize.
Okay, let's talk a little bit about the benefits realized. There were a lot of them in this, hard to count so many, but we have some highlight ones that I think you'll be very interested in. So when Amazon migrated 7,500 databases from Oracle to Amazon RDS and Aurora, and also 303 business critical services to DynamoDB, they actually did discover database freedom. Now, I don't know to everybody in the audience if 7,500 databases seems like a lot. It does to me, for sure. Some of the outcomes we saw were reduced operational costs, improved latency, reduced scaling efforts, and the important one, increased innovation. Managed services take away a lot of the heavy lifting and allow people to focus on their customers and innovating for their customers. Now, to migrate, Amazon leveraged data migration service. It's also referred to as DMS, and schema conversion tool, SCT is its short abbreviation. Those tools were very successful in helping our customer get to where they needed to be, and they get better all the time. So purpose-built databases allowed Amazon.com to choose the right tool for the right reasons. One size for all, it does not fit all of our use cases. It will be too expensive, too difficult to operate, so a change was necessary. Now, one of the biggest outcomes is, in the case studies that we produced, we saw a range of 40% to 90% operational cost savings. We saw latency improvements of 40%, but on that 40%, it was at 2x to 4x the load. So that's a double improvement for us. We also saw a reduction of 10x in administrative overhead. At a size of Amazon and that scale, that's a lot of savings. That's a lot of improvement. AWS Database Services take care of the heavy lifting and do the maintenance, allowing teams to really focus on innovation. Now, let's talk about some of the keys to success. There were actually quite a few. First, we use the right tool for the right job. I encourage you to take action and look at purpose-built databases. We actually saw cases where just moving helped create budget for teams to operate and hire new headcount because they were reducing their costs so much. In addition, really full leadership support on both sides was important. Also, being able to report to the VPs and keep everybody on the same page actually helped the integrity of the project and to keep it moving forward. We even saw some competition of teams wanting to move faster than others. On training resources, there's a lot of self-paced and class-based training, but work with your AWS team. We did, our solution architects did a number of deep dives, hands-on learning sessions, brown bag lunch sessions on how to migrate, but also on operational best practices. So work with your AWS team. They can bring a lot to the table on that. Now, the relationship between Amazon.com and AWS was also critical. We are different companies, and they help ask for services and push our services to the limit, and it helps make those services even stronger and better for others that will come and use them. And then finally, this was such a big project, we wanted to take a sampling of some of the lessons learned and interview some of the teams, and we did that through case studies. So you'll see a link up on the screen there. We've consolidated all the case studies into an innovators page for you all to review, and it'll show you a whole sampling of a lot of different kinds of teams with names you'll be very familiar with if you've shopped on Amazon or watched video on Amazon. They should be pretty common names to you. So some of the case studies actually include Amazon Fulfillment Technologies. They're referred to as AFT. If you've ordered anything from Amazon, it goes through their systems. You can see how they leverage Aurora for inventory for the database. You can also discover how Business Data Technologies leverages Redshift for analytics at scale. We've recorded a video on that. We did 2 sessions over the last 2 days, and that video will be on YouTube. You can see how we built our data lake and deprecated one of the largest Oracle data warehouses at the same time. You'll also see this story, the enterprise migration that Thomas and I are presenting today. There's a case study on that with more detail. There's also the wallet service. They increase performance for business-critical payment services with DynamoDB. And another one you may be familiar with is Prime Video. Prime Video has a great story. They migrated billions of rows from Oracle to DynamoDB and increased elasticity and reliability, but they did it all with no downtime and transformed their service into the next generation streaming service. That's an incredible feat. Another great story is Amazon advertising. If you watch sporting events or other live video, you may notice Amazon is more present in that space. And you'll see how they leverage RDS to simplify scaling so they don't have to provision against future traffic spikes. Now they just pay for what they use as they grow. It's really the perfect world for them. We also have a fraud detection team, the buyer fraud group. And there's been some announcements about new fraud detection at reInvent. Well, they didn't exist yet, and we had a team that leveraged DMS, the data migration service, to migrate to Aurora, which allowed them to simplify scaling and reduce their operational costs. They are getting the same performance as Oracle at half the price. That's a strong statement. That takes care of headcount, that helps contribute to the business. You can also see how our items and offer team increased availability by 10x. That's huge. And they had no downtime during their migration. That's a capability a lot of people would like to have. And then finally, we have a team called the Financial Ledger and Accounting Systems Hub team. Their nickname is the Flash team. And they leverage both RDS and DynamoDB, and they handle any level of transaction volume with that solution. As a note, the big outcomes from them is in their particular case study, they reduced their latency 40%, they cut their overhead by 70%, and cut their operational costs by 70%. incredible outcomes that help contribute to the business. If you think about it, who wouldn't want to dramatically cut their costs while improving performance in multiple factors? That's the power of AWS. That is why Amazon leverages AWS, is to deliver those kinds of results. So we want to make it easier. So this shot here, for anybody really interested, these are the playbooks. So we're in a complicated type of world. This should help simplify it and give some paths and directions on the different topics you might face. It might be Microsoft SQL to Amazon Aurora. Might be SQL Server to Aurora Postgres. There's a lot of different options up here. I hope you'll take a look at these. I think they'll help you move a little bit faster in your journey, okay? They're also located at aws.amazon.com/dms/resources. And then we'd like to wrap it up today. You've all come here to learn, and you've invested a lot of time to learn, but we don't want it to stop here. I hope you'll keep reinventing with resources from AWS training and certification in database. If you have teams that need to learn, I hope you'll take a deep dive on this. We've released some new training around database where maybe we've been a bit thin in the past. The options for database are getting more complex and diverse. And it causes some customers to have to do a lot of navigation, and we want to make that a little bit easier. We have a new database overview course that provides the full foundation in 4 hours. And we offer an introduction videos and primers on 7 different AWS database services. If you invest your time in this, it could really help your organization move even faster on this topic. These are new certification paths, and you know, certification paths come up all the time. I've been around for a while. I remember Novell to Microsoft. I remember VMware. I remember a lot of different things. There's a new time coming, and there's new certifications coming, and early adopters are the ones that typically are going to have some career opportunities themselves if they have demonstrated they've developed new skills. You can now validate your experience with an industry-recognized certification in databases. It's now in beta. So if you're interested or you know others that are, I hope you'll encourage them to follow that path and explore what they could do there, okay? You can also find information this on the aws.amazon.com/training site. And with that, we're going to wrap it up, and I'd like to bring Thomas Park back out onto the stage here and thank our wonderful customer, Amazon.com, for doing this migration and going down this journey with us. We hope you have a safe reInvent, and thank you for attending our session today.
Thank you.
All right.